Hi guys, welcome to Tutor Bedford. This is another video today and we're going to be looking at integration. Hi guys, welcome to another video. So today we're looking at forces and friction and we're going to be just focusing on sliding down a slope. So when a particle is resting horizontally, direction of motion to the left will have a normal reaction perpendicular to the surface, and the weight will act perpendicular to the surface. So we'll have normal reaction and a vertical line going down for the weight. So on an inclined plane, we have direction of movement going down. You'd expect the block to go down. And this time, you see the normal reaction, again, still perpendicular to the surface. But the only difference is the weight is going to act vertically downward. The weight is always acting vertically downward, and the normal reaction is always going to be perpendicular to the plane. So when an object is on an inclined plane, we need to consider the forces acting parallel to the plane and perpendicular to the plane. So here's an example. If we have a 3 kg block resting at an inclined plane at an angle of 30 degrees, then we'll have the weight acting downward, which is 3g. Now g is obviously due to gravity, so in maths we will use 9.8 and in physics we'll use 9.81. And we split up the forces. So if we've got a force of weight 3g coming downward, then we could work out this angle here, the missing angle. Now you know this makes a right angle triangle here. If this is 30 and this is 90, then this angle here must be 60. So we know angle in a triangle is that up to 180. So if this is 60, this angle here must be 30. So in a nutshell, all you have to do is remember this angle, the angle of the plane, and this angle here between the blue and the 3g line is always going to be the same. So now, because the hypotenuse of this right angle is 3g, and this blue line, the force here is the adjacent, that's going to be 3g cos 30, and parallel to the plane, the red arrow, that's the opposite side. So we've got opposite, we've got hypotenuse, so this must be sine, so it'll be 3g sine 30. So we'll have the normal reaction R, which is perpendicular to the plane. So let's take this question here. So we're told a box of mass 2 kg is resting on a smooth plane inclined at angle 20 degrees to the horizontal, and it meets a resistance of 2 Newton as it travels down the slope. Remember, the 2 Newton is resistance, so it's going to go in the opposite direction to the motion. So we asked to calculate the acceleration of the box down the plane, and then we asked to find the velocity of the box at the bottom of the plane. So same as before, we're going to start off by drawing a nice big clear diagram. We have the weight 2g coming down, and then as explained in the previous slide, this angle here is going to be 20 degrees. This is the adjacent side. 2g is the hypotenuse, so adjacent hypotenuse you need cos, so it's going to be 2g cos 20 coming down and 2g sine 20 coming down parallel to the plane. We have a resistive force of 2 Newton. Now that's going to go in the opposite direction of motion, and we have the normal reaction R. So now we're going to resolve parallel to the plane. So using Newton's second law of motion, F equal to ma. So everything parallel to the plane. So if you look at the diagram, I've highlighted it for you. So everything parallel is in red. So we've got 2 Newton going up the plane and 2g sine 20 Newton going parallel down the plane. So if we resolve it going down parallel to the plane, then 2g sine 20 is going to be positive, minus 2 because it's going the opposite direction. So these are your forces equal to ma. So your m is 2 times a. Now simply if you just solve that, it will give us the acceleration of 2.4 to 2 significant, but more commonly I would say give it to 3 significant figures. So for part B, we want to find the speed of the box at the end. So the distance is traveled is 10 meters. It was released from rest, so U is equal to 0. V is what we're trying to find. A we worked out, which is 2.4. And T we're not interested. So using simple SUVAT, we know we need V squared equal to U squared plus 2AS. Substituting the value, U is 0, so 0 squared plus 2 times 2.4 times 10. And I would always suggest that you guys leave your calculator display from previous working and use the calculator display or the answer button, so we always keep accuracy to minimum. So here V squared is equal to 47.03, so if you square root that, it will give the velocity of 6.6 meters per second. So now part C, we want to find the normal reaction between the box and the plane. So the normal reaction here we labeled it R. So we need to resolve perpendicular to the plane. So again, I'm going to color code this. If I put it in blue, everything perpendicular, you will see we have R and 2g cos 20. And since there is no acceleration perpendicular to the plane, it's just going to be 0 on the right hand side, 2 times 0. So if we resolve it, R minus 2g cos 20 equal to 0. Just rearrange it and put this in your calculator, and it will give us the R value of 18 Newton. Okay, so we could also have a situation where an external force is applied. So in this case, this block is getting moved up the plane. So we have a 2 kg block and a 4 Newton force, which is parallel to the plane, pushing it up. And sometimes, rather than giving the angle, it could be given as tan. And in this case, we've got tan alpha is equal to 3 over 4. So if we start labeling the forces, we have normal reaction, we have the weight 2g, and we have 2g cos alpha and 2g sine alpha. So what we're going to do first is work out what sine alpha and cos alpha are, because we need this as you can see on the diagram. So because we know tan alpha is 3 over 4, you just simply draw a right angle triangle, and going back to GCSE SOHCAHTOA, you probably remember. So the opposite side is 3, the adjacent is 4. So using simple Pythagoras theorem, you know this is 5. And this is a Pythagorean triplet. It's the standard 3, 4, 5 triangle. So now we have the triangle. You could work out what sine alpha is. Sine alpha is opposite over hypotenuse. Opposite is 3, hypotenuse is 5. So sine alpha is 3 over 5. And cos alpha adjacent over hypotenuse, so it's going to be cos alpha equal 4 over 5. Now if we resolve this parallel to the plane, so same as before, using Newton's second law, F equals to ma, we look at all the forces parallel to the plane. So you can see on the diagram it's highlighted red, and we're going to be resolving going down the plane. So in this case, 2g sine alpha is going to be positive, minus 4, because that's pushing it up. It's pushing up the slope, and that's equal to 2a. So now, because we worked out what sine alpha is, we could replace the sine alpha as 3 over 5, and g is 9.8. And if you just tidy that up, that should give you the acceleration 3.9 meter per square second to 2 significant figures. So in this example, we've got external force coming at an angle. So if we see an angle here of 60 degrees and a force of 5g applied to this block of mkg. And it's a show that question, so So we're going to use G all the way along our working, and we're going to try to give answer in exact form where possible. So as before, the mg is going to go vertically downward, and then we'll have mg cos 30, and then we'll have mg sine 30 parallel to the plane. Normal reaction, the only difference this time is with that 5g. So we need to make a right angle triangle here, with 5g being your hypotenuse. So on the opposite side, we're going to have 5g sine 60 coming down, and 5g cos 60 pushing it up. Because when you're pushing it in, you're pushing it both inward and parallel up the slope. So if we resolve, same as before, if we resolve parallel to the plane, so F equal to ma, and we're resolving everything going up as positive, up as in parallel to the plane going up. So 5g cos 60 going up minus mg sine 30 going down equal to ma, m times 0.5. And if we tidy that up, we're substituting cos 60 and sine 30 in our calculator, we get the following value. But we have to keep an eye on what the question said. It's a show that question, and we've got a lot of decimals here, so one way to get rid of it is simply just multiply everything by 2. Okay, and now here it's saying show that the mass of the particle is equal to. So it's obvious that on the right hand side you simply just factorize by taking m outside the bracket, and to make m the subject you simply just divide 5g by 1 plus g, and there we have it. We've shown what the question said. Okay, so you guys have a go at this question here. Just pause the video and have a look at this past exam question. Okay, here's the answer for part A. So part A, cos theta is equal to 3/5 is to show that question. Part B, normal reaction 90 Newton. And part C, if we resolve parallel to the plane, 49 cos 30 minus 6g sine 30 equal to 6a. So that will give you A as 2.17 meter per square second. Alright guys, thank you very much for watching this video. Please subscribe to my channel. There will be more videos uploaded every week. Thank you. Alright guys, welcome to Tutor Bedford. This is another video today, and we're going to be looking at integration.